Okay, listen up here, guys. Going to give you some tips and hints for your circular motion assignment. This marks the halfway point, actually a little more than halfway through this unit. So while you are working on this, I will be coming up with your unit exam date and putting it on the board. Okay? Now, this is just like any other assignment you've had in my class thus far. There's some problems that you need to solve. The point values are in bold and brackets after the question to give you some idea of how much work might be involved in that question. Okay? It covers everything from, okay, as simple as this and this. Okay, so some stuff that's that simple, like t equals 1 over f and v is 2 pi r over t, stuff like that. Okay, as well as banked curves, unbanked curves, vertical circular motion, artificial gravity. Okay, anything from this first half of the unit, okay, is game for being on here. This is usually a pretty good opportunity for people to improve their mark in the assignments category or classwork category of your mark. People usually do pretty well on this assignment, right? So, question number 1: tips of a fan blade, or tips of the blades in a food blender are moving at 21 meters per second in a small circle with a radius of 0.053. How much time does it take for them to make one revolution? Okay, so think about what you're solving for, what the time for one revolution is called. Okay. Question number 2, horses are racing around a circular track. It takes them 118 seconds with a speed of 17 meters per second. What's the radius of the track? Again, not difficult questions, just going over stuff we've talked about. Question number 3, you've got magnetic tape being spooled onto a reel. Right? So someone's just reeling this stuff onto the reel. Okay? The tape's moving at 0.191 meters per second. The radius of the wheel is 0.0762 meters. You're looking for the magnitude and direction of the centripetal acceleration of the tape as it is wound around the outer layer. Okay? We haven't asked for direction very much, especially when it applies to something centripetal, because that's kind of implied. But I need both magnitude and direction here. Okay? Number 4, race car going around a circular track with a known radius. Make sure you watch units here. Okay, goes around that track once in 360 seconds. You're looking for the centripetal acceleration of the car. Okay. Number 5, ball is shot from the plunger of a pinball machine. I don't know if everybody knows what a pinball machine looks like. Kind of a generation gap here. Not maybe all of you have played pinball. Okay, but suffice it to say, a metal ball about this big. You pull back a spring-loaded hammer and you let it go, and the spring pushes the hammer into the ball and shoots it off. Okay, so it goes around. Okay, it goes around. We've got its mass here. We've got the centripetal force. We know its radius. We're looking for the speed of the ball. Okay, again, not a difficult question. Number 6, we got a ball being whirled on a string. Okay, in a known radius circle. We know that it takes half a second for it to go around. We want to know the centripetal force. Then we want to know if the speed is doubled, does the centripetal force double? Okay. If not, by what factor does the centripetal force increase and why? Don't forget to answer that part of the question. People do the math on this one and then they forget to write down the explanation after. Okay? All right, number 7, bank curve question. So we have this curve that's we know has a radius of 150 and a speed of 25, and we want to know the angle of bank. Okay, number 8, okay, also a bank curve question. Number 9, talking about apparent weightlessness. Okay, when you go over the top of a vertical circle, so it's a vertical circle question. Okay, gives you all the information there. Number 10, also a vertical circle question, goes over the top of a hill. Okay, we know the radius and the mass. Number 11, roller coaster is at the bottom of a vertical circle, okay, and gives you some information there, so another vertical circular motion question. Number 12, demolition ball swings at the end of a 15-meter cable on the bottom of a vertical circle, okay. And number 13, we have an unbanked curve. In fact, 2 unbanked curves that are being compared. The key part of that is that the curves are both made of the same surface. So the interaction between the tires and the surface is identical for both curves. Okay? All right. You got the rest of the class to work on that. I'll put a due date up here in a minute. Okay. Due date for this, December 3rd.
that's quite a...
Okay, week from today, or sorry, week from tomorrow. Okay? Yeah, it is.
Okay, so